Assalamu alaikum class, I am your physics teacher Iram. We are revising chapter number 5, gravitation. Earlier we have discussed about mass of earth. Today our topic of revision is variation of gravitational acceleration with altitude. Variation of G, gravitational acceleration with altitude. What is meant by variation? Variation is a word derived from the word vary, which means change. Altitude is the word used for height. So we have to see how the value of gravitational acceleration changes with the height. Suppose this is the earth. We have taken the mass on the surface of the earth such that the distance between these two bodies was the radius of earth, because it is placed over the surface of earth. So the mass of earth comes out to be, mass was equals to g r square divided by g. Let's rearrange this formula. For small g it was gm divided by r square. This is a formula for this condition whenever the object is placed over the surface of earth and the distance between the center of earth and the center of this mass was equals to r. So we can write the formula for gravitational acceleration like this. Now suppose we have taken this object at some height above the center of earth. Now the distance between the centers of these two bodies, the earth and this mass, is increased. This is the radius of earth and this is the height above the surface of earth. So we can write the formula for this body which is present at a certain height equals to gm divided by r plus h whole square. There will be a factor of height added in the radius of earth, because in first case we have taken the distance between the two bodies as the radius of earth. Now the height will be added here. Now as you know that the gravitational constant and mass of earth are two constant quantities, we can write this equation as the relation 1 by r plus h whole square. This relationship shows that the gravitational acceleration varies inversely with the height. As you go upward, as you go at some height above the surface of earth, the value of gravitational acceleration will decrease. That's why the value of gravitational acceleration at hills is lesser than at the sea level. So we can say that the gravitational acceleration has its highest value at the surface of earth, because there is no height there. The distance between the two bodies is just the radius of earth. So whenever you go higher from the surface of earth, the value of acceleration due to gravity decreases. Just like the case whenever we throw a ball in the upward direction, its velocity will decrease and its acceleration due to gravity will also decrease. At the highest point its velocity becomes 0 and it will travel again in the downward direction, and again its velocity will increase and its gravitational acceleration will increase. So we can say that there is an inverse relationship between the value of g and the height above the surface of earth. Let's discuss some cases. Suppose we have taken the body at a height equals to 1 earth's radius. Let's take this height as same as the radius of earth. What will happen? From this equation we come to know gh equals to, and now here I am writing height to show the difference between these two gravitational accelerations, these two values of gravitational acceleration, because this is for the surface of earth, for the bodies at surface of earth, and this is for the bodies present at some heights. So it will be gm divided by r plus h whole square. Here we have to replace this height with r plus r whole square, we will have gh divided by 2r square. So gm divided by 4r square, or gh will be equals to 1 by 4 times gm by r square. What is gm by r square here? It is the value of gravitational acceleration at surface of earth. gh will be equals to g divided by 4. It means whenever we take a body at a height of 1 earth's radius above the center of earth, its gravitational acceleration will be reduced to 1/4. Again, if we want to take it at a height of 2 earth's radius above the center of earth, its value will be gh will be equals to gm divided by r plus 2r whole square. Don't forget to write square here. gh equals to gm divided by 3r square. gh will be equals to gm divided by 9r square, or gh will be equal to 1 by 9 gm by r square. This is the formula for g at the surface of earth, so we can write it like this. Hence, by increasing the distance, the gravitational acceleration will decrease as squares of the values, and factor r is also here, so we will get the values like this: g by 4, g by 9. Then if we want to take it h equals to 3r, then 3r plus r will be 4r, and there will be a 16 times reduction in its value at that distance above the center of the surface of earth. So that was the variation of g with altitude. Now we will solve the numericals related with this topic.
So girls, these are the problems related with our topic today. The statement of 5.5 problem is: calculate the value of g at the height of 3600 kilometers above the surface of earth. It means a height above the surface of earth is given. You can draw the figure for your convenience here. This is the earth, its center is represented. The object is present at a height of 3600 kilometers from the surface of earth. It means you have to add this height in the radius of earth. So what are the values given? gh, the height, the gravitational acceleration at some height is given. You can represent it like this: g and h like this. So height is 3600 kilometers. You have to convert it in meters. 3600 multiplied by 1000. In scientific notation, this figure can be written as 3.6 multiplied 10 raised to power 6. Now radius is a constant quantity. 6.4 multiplied 10 raised to power 6. Gravitational acceleration is represented by capital G. Its value is written, mass of earth. Then you have to put these values in formula. gh equals to gm divided by r plus h whole square, putting the values. Now here you have to keep one thing in mind, that as the multiple of 10 in radius of earth is 10 raised to power 6, and you have to add height here in this r plus in this denominator r plus h. So you have to convert this figure and the measurement given here in height, you have to write in it also in terms of 10. It will be easy for you to add it like this: 6.4 multiplied 10 raised to power 6 plus 3.6 multiplied 10 raised to power 6 whole square is here. Both of these values have 10 raised to power 6. Now you can take this value as common, 10 raised to power 6, and remaining will be 6.4 plus 3.6 whole square as it is. Then 6.4 plus 3.6 makes 10, and 10 raised to power 6 whole square as it is. Now 10 and 10 raised to power 6 can be simplified easily. Bases are same, parts will be added. 10 raised to power 7 whole square 10 raised to power 7 whole square will be 10 raised to power 14. When this value comes to numerator, its exponent will be changed. 40.038 multiply 10 raised to power 13 and minus 14, it will be 13 minus 14 minus 1. When you multiply this figure with 10 raised to power minus 1, the decimal will move 1.1 place backwards. So the value of gravitational acceleration at a height of 3600 km above the surface of Earth comes out to be 4 meter per second square, as given in the answer. This. Now 5.6. 5.6 is find the value of g due to Earth at geostationary satellite. The radius of geostationary orbit is 48700. Here you have to again draw a figure first so that you will know what is the value of radius of geostationary orbit. Suppose the satellite is here and the radius of geostationary satellite is taken from the center of Earth. It means this whole distance is given. R and H is also present in the geostationary orbit. So it means that this is not the height given, this is the radius of geostationary orbit given, which is r plus h. It means the whole value of r plus h is given to you. You have to look at it carefully, and you have to see the difference between the statement of these two numericals. There was the height given 3600 km above the surface of Earth, but in this condition, in this statement, it is the radius of geostationary orbit. So in that case you have to just write h as 3600 kilometers, but in this case you have to write r plus h equals to this figure given. Now gravitational acceleration is required. Small r represents the radius of geostationary orbit, which is equal to r plus h. It is 48700 kilometers. Again you have to write it in scientific notation. Now you can see here I have written 48.7. In scientific notation it will be 4.87. Why I have not written it like this? Because as the radius is, okay, now radius is not necessary here, so you have to just write, you can also write it as 4.87 into 10 raised to power 6. Gm divided by r plus h whole square. Putting the values, we will get this value in place of r plus h. In the denominator we have written the value 48.7 into 10 raised to power 6. We have to write it, you have to take its square and write it like this. 10 raised to power 6 square means 12. By solving all these values you will have 0.17 meter per second square. You have to just be careful about the height in these statements. The rest of the solution is same. In 5.7, the value of g is 4 meter per second square at a distance of 10,000 km from the center of Earth. Now this is a third type of statement. Here the value of g at a height is given at a distance of 10,000 kilometers. Now this is the height, this is the distance from the center of Earth. Again you can draw the figure here. This is the Earth and the distance is taken as 10,000 kilometers from the center of Earth. So you have to draw it like this. This is the distance from center of Earth and it is 10,000 kilometers. So r and h are included in this distance. You have to mention r plus h equals to 10,000 kilometers. Kilometers stands for 1000 meters. So by simplifying it we get 10 raised to power 7. Value of g is given, the mass of earth is required. You have to write the formula. First, GH equals to GME divided by R plus H whole square. Just put the values. In this case, R plus H is 10 raised to power 7. Just solve the exponents of 10 separately and rest of the measurements separately. You will get the correct answer. The answer will be 5.99 into 10 raised to power 24. It is approximately equals to 6.0 into 10 raised to power 24, which we have seen in the last topic, mass of earth, kg. 5.8 is also related with the topic. At what altitude? In this case, the altitude is required. The value of g would become 1/4 than on the surface of earth. It means we have to see at what height the value of gravitational acceleration will become 1/4 of its original value, which is at the surface of earth, that is 10 meter per second square. Now the height is required and gravitational acceleration is given, that you have to take it as the value of g on the surface of earth divided by 4. It is 1/4 of its original value. Ge is 10 divided by 4 will be 2.5 meter per second square. Mass of earth and gravitational constant. Write the formula here. GH equals to GM divided by R plus H whole square. As you have to find out just H, so you have to separate its part first. R plus H taken on the left side, GH will be divided. Here square is here, so first of all you have to change this square in the unit exponent. R plus H whole square will be cancelled with square root. On right side it will be GM by GH under root. Now you have to just find out the value of H. Take R on the right side, it is positive here, so it will be negative on the other side. H will be under root GM by GH divided by minus R. Now putting the values, you will have all these values. You have put all the values here and solve the exponents of 10 raised to 24 and 10 raised to power 11 minus 11 together. Multiply the rest of the values together. 40.038 divided by 2.5. Also do these measurements stepwise, otherwise there are chances of some mistake. Don't write all the values in calculator at one time. First of all solve the numerators, then solve the denominator, and then solve the exponents of 10. 6.4 into 10 raised to power 6 will be same in all the steps. Here 13 is here. You can see the exponent 13 is here. So first of all convert it into an even number so that you can take the under root easily. Don't multiply it with this number. Take the under root of this 10 raised to power exponent of 10 and this number separately. So it will be convenient for you to convert it in even number first. 13, it was 13. If you make it 12, the decimal will move 1 point forward. 160.152 to 10 raised to power 12. Now the under root of this value will be 160.152 will be 12.655, and 10 raised to power 12 exponent 10 raised to power 12 will be 10 raised to power 6, because the value of under root is 1 by 2, so it will be 10 raised to power 6. Now 10 raised to power 6 and 10 raised to power 6 is same. Okay, that's why we have I have write 12 here. 14 is also an even number. I can write 14. I can make this 13 into 14, but it will not be same as 10 raised to power 6. Then you have to be careful about the next measurements also, as you have to minus these, you have to subtract these two values, so you must have something common. 10 raised to power 6 is common in these two quantities. You can take it as common and subtract these two quantities, you will have 6.255 into 10 raised to power 6 meters, which is approximately equal to 1 Earth's radius, 6.4 into 10 raised to power 6. That was all about our today's task. In case of any problem, you can ask any question. Thank you.